Hello everyone, and welcome back to the Fluctus Channel. The MQ-25 Stingray was built to solve one of carrier aviation's most expensive habits, turning frontline fighters into flying gas stations. Instead of spending precious FA-18 flight hours hauling fuel for the rest of the air wing, the Navy pushed toward a purpose-built unmanned tanker that could launch from a carrier, climb out over open water, and extend the reach of everything around it. That immediately made the aircraft more than another drone. It became a new kind of deck asset, one designed not to replace pilots, but to buy them more time, more range, and more combat usefulness. At roughly 51 feet in length, with a 75-foot wingspan spread and a folded span of about 31.3 feet, the Stingray already sits in the size class of a serious carrier aircraft rather than a small surveillance system. That scale became real during the unmanned carrier aviation demonstration aboard USS George H.W. Bush in December 2021. Sailors did not treat the prototype as a novelty parked on deck for public interest. They towed it, aligned it, handled it through deck choreography, and worked it into a living flight deck environment where timing, clearance, and discipline decide whether operations stay smooth or collapse into danger. Once the aircraft rolled forward and launched from the carrier, the significance was obvious. The ship was no longer launching only manned fighters and support planes. It was launching endurance itself, wrapped in an unmanned airframe built to change how the entire carrier strike group manages fuel and range at sea. The program crossed its first historic threshold on June 4, 2021, when the MQ-25 test asset completed the first aerial refueling ever conducted between an unmanned tanker and a manned receiver aircraft, an FA-18 Super Hornet. Summer testing then expanded to the E-2D Advanced Hawkeye and the F-35C, proving that the drone could support some of the most important aircraft in the carrier air wing. The process is brutally exact. The tanker must fly a stable profile, deploy its hose and drogue cleanly, and hold that behavior long enough for the receiver to move in, plug, and take fuel without drama. Doing that without a pilot on board the tanker is why the MQ-25 feels genuinely futuristic. It is not just another aircraft. It is a new support logic for naval aviation, one built around unmanned persistence in the middle of the ocean. The deck routine around the Stingray is part of the message. Handlers still fold wings, watch spacing, keep taxi lanes clear, and connect the aircraft to the catapult sequence like any other deck asset. Nothing about unmanned aviation makes the carrier less demanding. It only changes who sits inside the vehicle. That means yellow shirts, handlers, and directors still have to trust the procedures, because a wingtip mistake, a bad alignment, or a launch delay matters just as much with a drone as with any fighter parked beside it on the deck. The MQ-25 is only one branch of a much broader American push into autonomy. The Air Force's Skyborg Vanguard was created to build an autonomy architecture that could let unmanned aircraft operate beside crewed aircraft in meaningful, repeatable ways. The concept was never about producing a robot ace that replaces the pilot. It was about producing loyal, attritable teammates that could sense, relay, scout, escort, or absorb risk, while human pilots made the highest value decisions. In simple terms, Skyborg aimed to increase combat mass without increasing pilot requirements at the same rate. That idea gained real shape through the autonomous aircraft experiment, which used multiple unmanned platforms to test how autonomy could behave in realistic operations rather than isolated demos. Aircraft such as the XQ-58A Valkyrie, MQ-20 Avenger, and UTAP-22 Mako became flying laboratories for this effort. The point was to push beyond basic flight and toward useful teaming, where an autonomous aircraft could hold position, respond to commands, and begin acting like a force multiplier. The attritable idea mattered because these aircraft were meant to be affordable enough to risk aggressively, rather than treated like rare manned assets too valuable to expose. The Valkyrie became the most recognizable symbol of that shift. It was designed as a runway-independent, low-cost, long-range unmanned aircraft with the speed and presence to matter in combat scenarios. In Gateway 1 testing, Valkyries operated in events involving F-35s, proving that autonomy was beginning to fit into the same tactical world as stealth fighters. The Marines pushed the same logic further through PAC-P, using the XQ-58 in joint test missions to explore how autonomous systems could support expeditionary forces. That is the link back to the MQ-25. One drone extends the air wing through fuel. The others explore how autonomous teammates may eventually extend combat itself. The experimentation process is what gave the concept credibility. Engineers validate autonomy on the ground, then in controlled flight, then in tactical scenarios where an uncrewed aircraft must respond, reposition, and stay useful around crewed jets. Attritable means affordable enough to risk, numerous enough to matter, and flexible enough to absorb dangerous tasks. That lesson matters because autonomy is not being treated as a laboratory toy. It is being pushed toward missions where machines must share airspace, timing, and tactical purpose with pilots who cannot afford confusion, hesitation, or unpredictable behavior once the exercise starts turning into combat for real conditions. The same search for robotic reach is moving across the sea. An unmanned surface vessel is a craft that can patrol, scout, relay, or test systems without a crew physically aboard, and that changes how navies can distribute risk. Smaller systems, such as the Manta's T-38 Devil Ray, point toward the shallow water version of that future, where a compact, robotic boat can move fast through restricted waters that might be dangerous or inefficient for larger crewed craft. The appeal is simple. More eyes and more presence pushed forward without exposing sailors every time the mission enters a risky stretch of water. Larger robotic vessels show how quickly the idea is expanding. In September 2023, the Unmanned Surface Vessel Ranger arrived at Fleet Activities Yokosuka during Integrated Battle Problem 23.2, marking the first such visit there by Unmanned Surface Vessel Division 1. Ranger had already been at sea during RIMPAC 2022, which meant the vessel was no longer trapped in laboratory conditions or one protected test range. It was operating in the Pacific, traveling long distances, and entering Allied ports as part of visible fleet experimentation. That matters because an unmanned vessel underway has to do more than move. It has to navigate, maintain communications, handle sea state, and remain useful over time. Events such as IMX and Cutlass Express 2022 widen the lesson further by putting multiple unmanned systems into the same maritime exercise space. That is the real point. The military is not experimenting with one robotic craft in isolation. It is building a broader ecosystem in which air drones, sea drones, and portable surveillance systems can all contribute to awareness and reach. What the MQ-25 is beginning to do for the carrier air wing, robotic vessels may eventually do for patrol, surveillance, and maritime security on a much wider scale. Exercises matter because they expose robotic boats to the same messy variables that confront crewed ships: weather, distance, combined operations, and the simple fact that the ocean rarely stays convenient. A craft such as Ranger arriving in Japan is therefore more than a port call. It signals that autonomous systems are learning to travel, integrate, and look normal in fleet practice. That shift matters because a robotic boat then stops looking like a remote test article and starts resembling a future scout or relay vessel, widening fleet reach without widening human exposure in the same far waters. The final layer of the story is portability. Not every unmanned system needs a runway, a flight deck, or a large support ship to matter. Some are moving toward the opposite extreme, where long endurance is paired with minimal launch infrastructure. The vanilla Ultra Endurance UAV demonstrated that logic through a land-launched flight using a vehicle-based setup instead of a conventional airfield. That matters because portability creates options. A force that can launch a surveillance asset from the ground with limited preparation can start building awareness far faster than one waiting for fixed infrastructure. The same principle appears in high-mobility launcher concepts used by European forces and in small American tactical drones. The launcher itself becomes part of the flexibility. The RQ-21 can be launched to support expeditionary training, while the Scan Eagle has already shown how a small unmanned aircraft can be launched and recovered at sea, giving ship surveillance reach well beyond the horizon. Once that happens, the idea of unmanned systems stops belonging only to billion-dollar programs. It scales downward to special operations teams, small units, and ships that need information without building a full runway or permanent drone base. That is what ties the whole story together. The MQ-25 shows autonomy at the top end of naval aviation, where a giant tanker drone changes carrier operations. Skyborg and Valkyrie show the same logic moving toward autonomous combat teammates. Ranger and other USVs carry it across the ocean surface. Vanilla, RQ-21, and Scan Eagle shrink it into portable surveillance. Different sizes, different services, different launch methods, but one clear direction. American forces are pushing drones toward more endurance, more autonomy, and more frontline usefulness. In the end, the tanker drone in the middle of the ocean is not an isolated marvel. It is the clearest sign that the future battle space will be crowded with machines designed to stay longer, go farther, and take on more of the burden before human crews ever arrive. Even the simplest launch method carries a larger message. The less infrastructure a drone requires, the more places it can appear, and the harder it becomes for an opponent to predict where surveillance will come from next. Portability, in other words, is becoming a weapon. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.